Welcome. My name is Brenden. Welcome to the stream. Welcome to my my series. It's Friday afternoon. I left work a little early today, and I thought I'd use my time to do a little Friday afternoon / evening, whatever. Time's it 5:20. I'm not sure if that counts as afternoon or evening. It's right on the border, right on the edge. Welcome to the stream. If you're new, if it's your first time, then thank you for dropping by. If you are a return viewer, then welcome. Let me do a sound check, make sure that my sound's actually working. I have a fairly low-tech monitoring system here. It's just my phone, and need to make sure. How do I see my stream on YouTube? There we go. There we go. Can you hear my voice? It's coming through. Sounds terrible. Perfect. We're good to go. All right. So let's dive into it. What are we doing here? So this series is about this book. It's called Cracking the Coding Interview. There are 189 programming problems in this book, and I have been going through each of the problems and solving them in Rust and simply talking through what I'm doing. My hope is that somebody will get some value out of this. Maybe if you have this book and you're trying to go through it, or you just want to learn more about programming, or you want to learn about Rust specifically. I'm doing the problems using a language called Rust. Then maybe you'll learn something. I don't really consider myself a Rust expert. I'm kind of learning the language as I go. And that's that. I've always felt that the best way to learn something is to try and teach it to somebody else. So that's what I'm doing, so that I can learn Rust really, really good, well, and properly like. Yep. Okay. So welcome. Let's take a look. See where we left off, where we are. Try to switch to the right screen here. So here's the project up on GitHub if you want to check it out. Make sure I'm on the right screen. Doge, what's wrong? Why are you whining? No whining, puppet. So you can go on GitHub, go to github.com/my name, no vowels, Brenden Matthews /cracking the coding interview Rust with dashes in there in the name. You can check it out. All of the source code is up there, and I have basically recorded all of my work on all of this with I've edited the README a couple of times to add in the links to the old videos and stuff like that. But for the most part, I have done it all live here. I'm streaming both to YouTube and Twitch, and you can, consume it in whatever way you prefer, whatever works best for you. If you join the live stream, then that's nice because you can join the chat and you can ask me questions, and hopefully learn something or get some value out of it. Try to be entertaining. It's a little difficult to actually talk about writing code while actually writing code, especially because I've never been through this book. I haven't done these problems. Well, not these exact problems. I've done plenty of interviewing problems, but not necessarily these ones. So, I'm learning it as I go, figuring it out. So, I think last weekend, I finished up chapter 5. Whoops. If I recall correctly. So yeah, we are done up to chapter 5. So the next chapter, let's take a look at it. Let's see what it is. Chapter 6. I haven't looked ahead at these problems, so I'm just kind of figuring out as I go. I will, however, mention that up till now, I haven't really cheated on any of these, so I haven't tried looking up solutions until after I've solved the problems. So I might break that now going forward, simply because I sometimes spend a lot of time just kind of figuring out the problem, and I'm worried that if it's taking me too long to actually just like get to the solution, then it kind of detracts from the quality of the stream possibly. So if I get to the point where I've spent a bunch of time on it and I can't get to the solution during the stream, then I might just actually read the solution first and then go back and solve it. There isn't really much point in me, I think, just kind of banging away at the keyboard until the right answer comes out. It's probably a waste. So chapter 6, let's get into it. It's called, it's about, I guess, math and logic puzzles. Please focus, camera. This is a problem every time. My camera gear is not good at focusing, at least not on the book. It seems to be okay with my face, I think, as far as I can tell, but not on the book. Okay, so let's look at the problems. First problem here, chapter 6, problem 1. Let's do it. Okay, focus. Can I focus on my hand? Can you focus? Oh, there we go. The heavy pill. You have, my lighting is not good. I may need to get some improved lighting. I have very uneven lighting, and it's kind of messing things up. So, all right, the heavy pill, you have 20 bottles of pills. 19 bottles have 1 gram of pills, or 1 gram pills, sorry. You have 20 bottles of pills. 19 bottles have 1 gram pills, but one has pills of weight 1.1 grams. Given a scale that provides an exact measurement, how would you find the heavy bottle? You can only use that scale once. All right, so I think I've heard a variation of this problem before, actually, which was based on gumballs, but I don't actually remember the solution. Let me think about it. I'm not a very smart person. I've got enough brains to get by, but I am by no means a genius like the book author, Gail. She's a total genius, total genie. Me, I'm just a dumb pleb. Is that a real word, or is it? I mean, I know it's a word. But is that a short for something? Plebiscite? No, plebiscite is like a rule. I don't know. Okay. Anyway, you have 20 bottles of pills. 19 bottles have 1 gram pills, but one has pills of weight 1.1 grams. Given a scale that provides an exact measurement, how would you find the heavy bottle? Okay, so find the heavy bottle. What does that mean? You have 20 bottles of pills. 19 bottles have 1 gram pills, but one has pills of weight 1.1 grams. I see, okay. Given a scale that provides an exact measurement, how would you find the heavy bottle? You can only use the scale once. You can only use the scale once. Yeah, this is definitely a puzzle one. A little puzzle trick. I don't know the answer. These problems annoy me. They get me going. They get me going. I don't like them. Doge's going crazy. Just having Doge puppy party playtime right now in the bedroom. 20 bottles of pills. 19 bottles have 1 gram pills, but one has pills of weight 1.1 gram. Given a scale that provides an exact measurement, how would you find the heavy bottle? You can only use the scale once. So let's just think about what we know here. It doesn't say anything about how many pills are in each bottle, but one can assume that all the pill bottles are about the same size, which means that 19 of those bottles should be less heavy than one bottle, right? The fact that you can only use the scale once means that you basically have to measure, you can only measure one bottle once, and then after that you would have to compare the weight of the other bottles. Also, I just realized that like this chapter doesn't involve writing any code, does it? Or does it? Does it actually? Because like this problem isn't really a coding problem. This is a propose a solution problem, which is fine. I'm just gonna talk through it. Although let me just see if there are actually solutions to this that are code, or if I'm just looking at oh yeah, no, there are there's a lot of code here. Okay. Well, maybe I'm not sure what the code would look like for this particular problem. Like what would I be writing out here? Yeah, okay, I'm looking at the solution for this first problem here, and there's no code. It's just a paragraph of text with an equation there. That is the first one. The next one, also no code. The one after that, no code. Yeah, basically none of these problems are solutions that involve code. With, well, maybe a couple exceptions. There's a couple problems near the end of the chapter that have code. Like problem, what is this? Problem 10. There's like there's some code here. And not solution. All right. Well, I'm just gonna talk through these questions then, I guess, until I arrive at one that. Oh yeah. Okay. So there's, if I look at problem 10 here, it says it's basically a problem, and then it says at the bottom it says follow up. Write code to simulate your approach. So I suppose none of these problems are intended to actually involve writing code, which is not really what I want to do, but I mean, yeah, whatever. Let's do it. Let's talk through these problems. All right. You have 20 bottles of pills. 19 bottles have 1 gram pills. Blah 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 blah. So if you can only use the scale once, that means all you can do is measure one bottle, and I suppose it doesn't say that you can't compare the mass of bottles. The only thing I can think that would make sense is if you measured one and then you compared that bottle to the mass of, like if you had like a balance or scale or whatever, not a scale, but just like a balance, some way to balance two things. You could compare the mass of the one bottle that you measured to every other one, and presumably, assuming the bottles are the same size in terms of number of pills, that bottle would either be the same mass as every other bottle, or more or less. Or actually, that doesn't make sense, because if you had a balance, if you had a way to compare the bottles, then you wouldn't actually need a scale at all, because it's not asking you to like measure the mass of anyone. It just says that you have a scale and you can use it once. Okay. Although perhaps it means when it says scale, use the scale once, maybe it means like per bottle. I don't know. It would probably say that. Provides an exact measurement. How would you find the heavy bottle? Well, I don't know. Let's read the solution, because I don't really know. Not smart enough. Don't got the brains. If somebody asked me this problem in an interview, I would probably just say I don't know. All right. It says, here's the solution. It says, sometimes tricky constraints can be a clue. I assume it's referring to using the scale once. Yes, no doubt. What does it say? It says, because we can only use the scale once, we know something interesting. We must weigh multiple pills at the same time. In fact, we know we must weigh pills from at least 19 bottles at the same time. Otherwise, if we skipped 2 or more bottles, oh, I see. So the thing that I didn't think about is they're saying, okay, this makes sense. If you take, this is actually really easy. If you take 1 pill out of every bottle and you weigh it and you keep track of like which pill came out of which bottle, yeah, you could figure it out. That makes sense. Take 1 pill, it says take 1 pill from bottle 1, 2 pills from bottle 2. Yeah. Right, okay, I see. So you can't keep track of the pills, but you're allowed to take a different number of pills from each bottle. I don't know. All right, I never would have figured that out. If this had been an interview, I would have failed that question in real life. So I guess I don't have what it takes. All right, problem 2, basketball. These codes, these problems have literally nothing to do with programming. Like absolutely nothing to do with programming at all. These are just brain teasers, but let's do them anyway. Basketball. You have a basketball hoop and someone says you can play 1 of 2 games. Game 1, you get 1 shot to make the hoop. Game 2, you get 3 shots and you have to make 2 of 3 shots. If P is the probability of making a particular shot, for which values of P should you pick one game or the other? You get 1 shot to make the hoop, or you get 3 shots and you have to make 2 of the 3 shots. Okay. Well, if P is, I don't understand, for one, it says for which values of P should you pick one game or the other. Well, what are you optimizing for? Like, what if my goal is to get 0 points? Or am I supposed to be getting as many points as I can? And how does it work? Which are these like 1, 2, or 3 points per shot. It doesn't say any of this stuff in the problem. I don't know. But I guess this is just some basic probability stuff, right? If you get one shot to make the hoop, and if P is probability of making a particular shot, for which values of P should you pick one game or the other? I have no idea. I don't have any idea. Let's jump to the solutions. I'm not spending time on these things. Basketball. You have a basketball hoop and someone says blah blah blah. All right. What is the solution according to this? It says, I wonder how many of these problems are just like literally copied out of the Google internal problem database or whatever. Probability of winning game 1 is P by definition, okay. And probability of blah blah blah, yeah, okay. So which game should you play? You should play game 1 if P of game 1 is greater than P of game 2. Okay. So play game 1 if P is less than 0.5 and greater than 0, and game 2 if P is less than 1 and greater than 0.5. All right. I learned nothing from that problem. I still don't really understand what the point of it is, honestly. I think I'm currently focused too much on the details of basketball and whether these are 1 point, 2 point, or 3 point shots, and I don't know. Okay. This is a bad chapter. I don't like this chapter. Has nothing to do with coding. This chapter is literally not about coding at all. There is if anything, I would say maybe it's about like math and puzzles, but neither of those things are things I consider myself good at. Certainly not. All right, dominoes. Please be focused. There's an 8x8 chessboard in which 2 diagonally opposite corners have been cut off. I don't know what that means. You were given 31 dominoes and a single domino can cover exactly 2 squares. Can you use the 31 dominoes to cover the entire board? By providing an example or showing why it's impossible. There's an 8x8 chessboard in which 2 diagonally opposite corners, so that means 1 square, have been cut off. All right, so 8x8 is 64 minus 2, that's 62. So there are 62 squares, and you have 31 dominoes and each can cover 2 squares. Can you use the 31 dominoes to cover the entire board? I think the answer is no, because you have an odd number of squares around the edge, and you can't cover if you have an odd number of squares, you can't cover an odd number. I think that's the answer. Let's jump to the solution. I don't know. I'm just guessing. Solution. At first, it seems like this should be possible. It's an 8x8 board. When we try to lay them down, blah, blah, blah. Okay, for each row, each domino, therefore, Oh, so it is impossible. Yeah, I was right. Okay, next one. Ants on a triangle. Well, I got one. Woohoo! Thankfully, in my experience, nobody asks these kinds of questions anymore. Like these specifically, these like brain teasers or whatever. This stuff just never gets asked anymore in interviews. Not never, but I can't recall having been asked problems like this within the past couple of years. So, no, yeah, I mean like within the last, I don't know, 5 years, I'll say. I don't think so. So that's good. Although I think if you were trying to get a job that was like a little heavier on like math and probabilities and stuff like that, maybe even data science, then you might get questions like these, but I don't know. I can't speak to that. All right, this one is called Ants on a Triangle. It says there are 3 ants on different vertices of a triangle. What is the probability, please be focused, what is the probability of collision between any 2 or all of them if they start walking on the sides of the triangle? Please be focused. There are 3 ants on different vertices of a triangle. What is the probability of collision between any 2 or all of them if they start walking on the sides of the triangle? Assume that each ant randomly picks a direction, with either direction being equally likely to be chosen, and that they walk at the same speed. Similarly, find the probability of a collision with n ants on an n-vertex polygon. Fuck, I don't know. I have no idea how to solve this. This is again, has nothing to do with programming. This is like just math, which is like this kind of pure math is not really a thing that I have done since like school. So honestly, I don't know. I'm sure I could figure it out with like some research, but it's not something I do daily. So let's see. What is the probability of collision between any 2 or all of them if they start walking on the sides of the triangle? What does that mean, on the sides of the triangle? Assume that each ant randomly picks a direction. There are 3 ants on different vertices. Okay, so an ant at each vertice. Assume that each ant randomly picks a direction, with either direction being equally likely to be chosen, and then they walk at the same speed. So I get it. So you have a triangle and you have 3 ants. The probability that they would not collide. So the case where they would not collide is if they all turn in the same direction, right? So if they all walk the same way around the triangle, then they wouldn't meet. But if any one of the 3 ants changes direction, then they will collide. Hello, Resistor. Question about Rust. You have a little project used internally. Okay. Is Rust ready for production? That's a good question. I think it depends on what you're doing. The language itself is definitely production ready. The crates, the libraries, I would say they are not very mature. So if you're talking about like internal microservices, especially like HTTP stuff, my experience the ecosystem. Yeah. So for like internal microservice stuff, I think the main problem that you're going to have is that you know, like if you build the thing in Rust, it would probably run and work and everything. The problem is that even if the you know, whatever library or crate that you're using works fine, you're probably going to run into issues when you want to do things like instrument it or like integrate with some kind of third-party tooling. For example, for like service stuff, the library that I have used with Rust for building HTTP services has been a library called Rocket. You can go to let me just show you. You can go to rocket.rs. This is the library I've used. It's still a pretty, it's still a pretty new library, but like one thing that is completely missing from this library, as far as I know, is a way to do metrics, for example. So like almost every single mature like HTTP thing has some way to deal with metrics, just like out of the box, as an example. So like you would have to write everything yourself, and it's not that hard, right? I'm sure there's like a Rust statsd library somewhere. Yeah, like here's one, statsd, a client. So you know, like you could trivially instrument all this stuff, but you know, I'd say like in the context of like real life services and stuff, generally you wouldn't want to have to build all that kind of stuff yourself. Like for example, to do tracing, if you've used like Datadog's tracing or like New Relic or one of those libraries or like SDKs, that kind of stuff is super useful, but you know, like the Rusty ecosystem just doesn't have that kind of stuff yet. It's just not that mature. But then again, if you don't need that, then yeah, go for it. I think there's certainly a trade-off and a risk. Like you get a lot from Rust in terms of safety and performance and so on, but at the same time you're giving up access to you know, a more mature ecosystem. But like truthfully, if it were me in like my day job situation, I would probably not use Rust. I would use, you know, if it's like a one-off service thing, I would probably use like a Python and Flask, or like one of the Java things like Spring, or you know, whatever. Just because like just has like everything out of the box. You don't have to like reinvent everything. Prometheus, yeah, there's probably there's probably like a Prometheus. There is an instrumentation library, but still, like, you could use this, but you would still have to manually instrument everything in your service. So like, you know, you would end up having to write so much, like build so much code that it might not be worth the effort, right? Like if this is something you're going to spend a couple of days on, or like a few weeks on, then it's probably not worth the effort. If it's something that you want to invest a lot of time and energy into, then like maybe it's worth actually adding this as like a proper feature, like a way to instrument calls in Rocket and so on. But yeah, I don't know, it depends. The other thing is like there's no general, I don't think there's like a general way to instrument Rust programs, like unlike something like something running on the JVM, there's no like standardized way to do that. It's just like a regular process. It's like doing it in C basically. So you have to do everything yourself. That's the downside, but that's not necessarily a deal breaker. I don't know, it depends. I personally have never used Rust in like any day job scenario yet, but you know, I'm looking for an excuse to use it. I'm more likely to use like Python, Java, or Go, something like that. Even Go is like pretty good because, you know, the ecosystem is like so mature. All right, so ants on a triangle. Yeah, right, sorry. What is the probability of collision? Ants on a triangle. So if only one ant switches direction, then there will be a collision. The only way there's not a collision is if all ants go in the same direction. So the probability of all ants choosing the same direction is going to be 50% plus 50% plus 50%. Not plus, it'd be like multiplied. So, you know, that's like 1 in, let me just calculate that. It's like 0.5 to the 3, right? So that's 0.125. That is the probability of them not colliding, which means the probability of them colliding is, you know, 1 minus 0.125, whatever. All right. My computer's fan switched on. That almost never happens. All right, let's look at the next one. We're just kind of flying through these. These are kind of fun to talk through, but they're not really coding problems. Jugs of water. You have 5-quart jug, 3-quart jug. Wow, this reminds me of high school. And an unlimited supply of water, but no measuring cups. How would you come up with exactly, I remember this problem from like high school. How would you come up with exactly 4 quarts of water? Note, the jugs are oddly shaped, such that filling up exactly half the jug would be impossible. All right, and an unlimited supply of water. So, all right, so we're looking for what, 4 quarts of water? So I can take, all right, so 5 minus 3 is 2, right? And 5 minus 3 is 2, which means if you fill up the 3-quart jug and then pour that into the 5-quart jug, then there are 2 quarts of capacity left over. Yeah, so what you can do, you can also do it the other way. So what I think you would do is you would fill the 5-quart jug to capacity, and then you would pour it into the 3-quart jug and collect all the spillage, basically. So you or whatever's left over, you use the 5-quart jug, you fill the 3, yeah, exactly. Then you have 2 left over in the big one, and you pour that 2 into some other container, and then you just repeat that. You empty out the 3 and do it again. All right, easy. Next one. Blue-eyed island. A bunch of people are living on an island. I think I've heard this one before too. When a visitor comes with a strange order, all blue-eyed people must leave the island as soon as possible. There will be a flight out at 8 p.m. every evening. Each person can see everyone else's eye color, but they do not know their own, nor is anyone allowed to tell them. Additionally, they do not know how many people will have blue eyes, although they do know that at least one person does. How many days will it take the blue-eyed people to leave? Okay. A bunch of people are living on an island. When a visitor comes with a strange order, blue people have to leave. There will be a flight out at 8 p.m. every evening. Each person can see everyone else's eye color, but they do not know their own. They do not know how many people have blue eyes, although they do know that at least one person does. How many days will it take the blue-eyed people to leave? Okay. So, do these planes have unlimited capacity? I guess one day for the blue-eyed people to leave. All blue-eyed people. So it doesn't say how many people there are, and it doesn't say how many people per flight. It just says a bunch of people living on the island, and okay. They do not know how many people. They do know that at least one person does have blue eyes, but that one person does not know they have blue eyes. And each person can see everyone else's eye color, and they're not allowed to tell them their eye color. One. All right. I don't know. This question is not it's not clicking for me. Blue-eyed island. Let's see. I see. Okay. So it says blah blah blah. So it says if one person has blue eyes, then that person would look around and realize no one else has blue eyes, and so they would take the flight that evening. Right, makes sense. If two people have blue eyes, the blue-eyed people will see each other, but are unsure whether that means there are one or two. They know from the previous case that there's at least one blue-eyed person, and that person would leave on the first night. Therefore, if the other person is... I mean, this doesn't actually make sense, because so they're saying that they would take two nights if there are two people, but yeah, it says if C people have blue eyes, then it takes C nights for blue-eyed people to leave. Then it says all will leave on the same night. I don't understand that statement. That doesn't make sense. All right, I don't like that problem. I think if somebody asked me that problem in an interview, I would just be like, I don't know. Sorry. Good luck. Good luck with your life. All right. Let's read this one. The apocalypse. In the new post-apocalyptic world, the world queen is desperately concerned about the birth rate. Oh my. Therefore, she decrees that all families should ensure that they have one girl, or else they face massive fines. So it's like the one-child policy of China except in reverse. Switch the genders around. If all families abide by this policy, that is, they have continued to have children until they have one girl, at which point they immediately stopped. What will the gender ratio of the new generation be? Assume that the odds of someone having a boy or a girl on any given pregnancy is equal. Solve this out logically and then write a computer simulation of it. I'm not going to write a computer simulation. I'm just going to talk through it. But, all right, so if the probability is 50-50 of having a girl, and you have to have at least one girl. Okay, so if on the first attempt you have a girl, then you stop. Probability of that is 50-50. The likeliness that after the first attempt you have a girl again, the probability basically goes up, right? You have two, why is this not focused? Whatever. Like the probability that you have a girl increases with each additional child that you have, right? It's like 1/2 times 1/2. No, not times. It's again 50-50 for this on second. Yeah. Hold on. I may be making a mistake here in my thinking. Let me change this. So, whoops, I don't want that. Well, the probability, yeah, the probability of any child, any individual child is always 50-50 of being a girl or a boy, right? But what was the question we're asking here? What will be the gender ratio of the new, what? Solve this out logically and then write computer simulation. Okay. Right. Okay, so there are going to end up being a lot more boys than girls, right? Because you stop as soon as you have a girl. And because it's 50-50 each time, then how do you figure out the ratio? I don't know. It's not going to be precise. It would be imprecise. I guess that's why it's saying you should write a simulation. Solve this out logically. I don't know. Let's see what the solution says. Right. Okay. Interesting. All right, it says, so yeah, the probability of having a girl is 1/2. The probability of having a boy and a girl is 1 in 4. Probability of having a boy and a girl is 1 in 8. Makes sense. Okay. So it says, what does it say? If you have 100 iterations with rand between 0, 1, boy, girl, you can calculate average. Yeah. So the book says, this is in the solutions chapter. Probability, number of boys, so it says, you probably won't know this off the top of your head, but we can try to estimate. Let's try converting the values above to a common denominator of 128. Okay. Looks like it's going to inch closer to 128 over 128, which is of course 1. This looks like intuition is valuable, but it's not exactly a mathematical concept. It's a clue though. We can turn to logic here. Should it be 1? Huh, okay, so they're saying this, the book is saying that you will have the same number of boys as girls. Interesting. And then there's a simulation. Huh. Okay. Guess I'm not smart enough. There's code in here and it says, yeah, if you run the simulation, you would get very close to 0.5. Half boys, half girls. All right. Cool. Well, I would have failed that question. Let's see, what's the next one? The egg drop problem. I think I've heard this one before too. Where is it? The egg drop problem. There's a building of 100 stories. If an egg drops from the nth floor or above, it will break. If it's dropped from any floor below, it will not break. You are given 2 eggs. Find n while minimizing the number of drops for the worst case. Right, presumably you would just do a binary search. You'd start it halfway. You would drop the egg, right? You're given 2 eggs. Find n while minimizing the number of drops for the worst case. So if you only have 2 eggs and you drop both those eggs, then you're out of eggs, right? I'm not sure there's a better way to do it than a binary search. Let's see what the solution is, according to the book. Solution, egg drop problem. The answer is really long. Drop. So it does look like you get to do more than 2 drops according to the code here. It says you should use the quadratic formula. All right, the solution says we may observe that regardless of how we drop egg 1, egg 2 must do a linear search from lowest to highest between the breaking floor and the next highest non-breaking floor. For example, if egg 1 is dropped from floors 5 and 10 without breaking, but it breaks when it's dropped from floor 15, then egg 2 must be dropped. Worst case, from floors 11, 12, 13, 14. All right. Yeah, whatever. Okay. No shit. There's only 2 problems in this chapter left. Let's just do them. Talk through them. I'm not going to write the simulation code. I'd prefer to stick with like actual programming problems. Okay. 100 lockers. Please focus. Computer. There are 100 closed lockers in a hallway. A man begins by opening all 100 lockers. Next, he closes every second locker. Then, on his third pass, he toggles every third locker. Closes it if opens it slowly. The process continued for 100 passes, such that each pass I, the man toggles every ith locker. How many lockers are open? So 100 closed lockers in a hallway. A man begins by opening all 100 lockers. Closes every second locker. Closes every third locker. So what's interesting is that this algorithm is actually an implementation of the sieve of Eratosthenes, which is a way to find prime numbers. The process continues for 100 passes, such that each pass I, the man, toggles every ith locker. Yeah. After his 100th pass in the hallway, in which he toggles only one locker, how many lockers are open? So the number of lockers that are open is equal to the number of prime numbers between 1 and 100. Whatever that is. I don't know. Okay, next problem. I'm satisfied with that answer. You have 1,000 bottles of soda and exactly one is poisoned. You have 10 test strips in which can be used to detect poison. A single drop of poison will turn the test strip positive permanently. You can put any number of drops on a test strip at once, and you can reuse the test strip as many times as you'd like, as long as the results are negative. However, you can only run tests once per day, and it takes 7 days to return a result. How would you figure out the poison bottle in as few days as possible? All right. Exactly one is poisoned. You have 10 test strips, which can be used to detect poison. All right. Well, you can test. You've got 10 test strips, and it takes 7 days. So you test 10 at once. When you've tested those 10, you test the next 10, and so on, right? I don't understand what else is to it. Let's see what the solution says. Observe the wording of the problem. Okay. Why 7 days? Why not have the results just return immediately? The fact that there's such a lag between starting the test and reading the results likely mean that they'll be doing something else in the meantime. Okay, running additional tests. Let's hold on to that thought, but start off with a simple approach just to wrap our heads around the problem. Naive approach, 28 days. Simple approach is to divide the bottles across the 10 test strips. First in groups of 100, and then wait 7 days. When results come back, look for tests, blah, 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 and repeat. Okay? Great work. That's the naive approach. Optimized approach, 10 days. Divide the bottles up into 10 groups with bottles 0 to 99 going to strips 0, bottles yada yada. Dividing the bottles in a different way can reveal the second or the third digit. All right. I don't think I fully understand this. So it says optimal approach takes 7 days, but you can only test 10 at a time. We can actually optimize this to return a result in just 7 days. This is the minimum number of days possible. Notice that what each test strip really means. It's a binary indicator for poisoned or unpoisoned. Is it possible to map 1,000 keys to 10 binary values such that each key is mapped to a unique configuration of values? Yes, of course. This is what a binary number is. We can take each bottle and look at its binary representation. If there's 1 in the ith digit, then that will add a drop to this bottle's contents to test strip I. So 10 test strips will be able to handle up to 1,024 bottles. Okay. wait 7 days, and then read the results. All right, I get it. I'm kind of cheating, but makes sense. Okay. All right, that is it for chapter 6. Let me take a look at chapter 7. I mean, maybe chapter 6 doesn't really seem like a code writing chapter, but it looks like... What is chapter 7? Is chapter 7 the code writing chapter? Chapter 7 is called Object-Oriented Design, which is not a very good chapter for Rust, given that Rust is strictly not an object-oriented programming language. But maybe what I should do is implement the simulations for those problems that add simulations. Explain how you would design a chat server. This one also looks like a non code writing chapter, which, no, that's not true. There's actually there's a question which is design and implement a hash table which uses chaining, linked lists, to handle collisions. What does that mean? Well, chaining is a method. So the way a linked list works is that you compute a hash, or sorry, the way a hash map works is, or hash table, is you compute a hash on a key, and then that key corresponds to a bucket, so-called bucket in the hash, and you usually have a fixed number of buckets. So if you have two different keys that correspond to the same hash, then chaining is where you store the values in here we go. Chapter 8 looks a little more interesting. Yeah, you would store the values in a linked list if you are chaining. All right, I'm just looking through chapter 7. Questions are: deck of cards. Design the data structures for generic deck of cards. Okay, can do that. Question 2, call center. Design classes and data structures for this problem. Design a musical jukebox. Design a parking lot. Design data structures for an online book reader system. All right, I think these problems would be fun. I'm not going to implement these simulations for chapter 6 unless if someone really wants me to, then I'll do it. Just get on Twitter or whatever, tweet at me, or open a ticket on GitHub if you want, and I'll do it. If I was hiring a React developer, what would I look for? Good question. I mean, I suppose like the skills that are involved in working with React are no different from any other programming language for that matter. However, if you expect someone to do React specifically, then I would just give them a problem that is like a React thing, like just say like give them some boilerplate, like some kind of starter thing, and then say like I don't know, ask them to like write a problem for you, like say implement a very basic word processor or something like that, or you could be like write a game. You could say I don't know, one problem I was given was someone asked me once to make a implement the snake game in JavaScript. That's something you could do in React. Another one might be like word processor or something like that. That's the kind of problem I would do probably. the problem with those, like those more practical tests, is that, yeah, ones like snake are pretty good. I like that snake one, actually. That was a fun problem because it's kind of tricky, but not super tricky. Like anyone who's reasonably good at programming should be able to figure that out. It's kind of fun to do, and most people know or have an idea of what snake is. It might take a little longer though. Like if I were to give someone that problem in an interview, like an on-site interview, I would give them at least a couple of hours, like maybe a 2 to 4 hour block of time to get through it, and then just see what they did at the end. And I mean, you can let them start from scratch or give them some boilerplate to get started. If you want to shorten the interview time, then I would say just give them a bunch of boilerplate, like a framework to start with, and then either pair with them or sit with them and just see how they do it. I personally think that coding interviews should be as close to how you actually code things in real life as well. So generally people should have access to all the different online resources like documentation and Stack Overflow and whatever that you normally would, with the only exception being that, like, if you ask them to make a snake game, then they should not go on Stack Overflow and search for give me a snake game with React and then like copy and paste all the code. That would not be acceptable, obviously. They should actually like build it. Okay. Anyway, chapter 7, object-oriented design. So like I was saying, Rust is quite literally not an object-oriented language. I would describe it more as it's more like a functional language, I would say, or closer to functional. I mean, strictly, I think if you looked at the Wikipedia page, it would probably say multi-paradigm or something. Let's see. Let's look at Wikipedia. See what it says for Rust. Probably says multi-paradigm. Or something like that. Yeah, multi-paradigm, exactly. It says multi-paradigm, concurrent, functional, generic, imperative. I would describe Rust as being more on like the functional and generic side. So it has functional features, and it has traits, and it has generics. Those are the main abstractions, I guess. But that said, you can, with traits, you can effectively implement object-oriented design. In practice, it's really the same thing. So this chapter I will go through. I don't think I'm going to start on it today. I'll probably get into it tomorrow. I'm not going to do these simulations from the previous chapter. I'm basically just going to skip over chapter 6, even though I talked through these problems. I would prefer to just stick to like the coding problems, pure coding problems, rather than doing any of these puzzle things. Also, I was just talking about doing a game problem in for like with React or something, and like there's a problem in chapter 7 here that is Minesweeper. Design and implement a text-based Minesweeper game. This would be a cool one too. You could do that with React. Yeah, anyway. I don't remember how Minesweeper works, so I'll have to figure that out. Interesting. Okay. So Chapter 7's next. I think this the problem count on here is a little overinflated. I guess like there are 189 problems, but like some of them are not really programming problems. Like pretty much all of chapter, not all of chapter 6, but most of chapter 6 are not really programming problems. They're mostly math and probability brain teasers. I don't think that counts as programming, in my opinion. But who am I? Who am I to say? It's not really for me to decide what's right, what's wrong. To each their own. All right. I think I'm gonna call it a day. I will. Oops, I forgot to put my book. I just closed the book. Forgot to put the bookmark back in. I have to find chapter 7 again. Might be hard. Let's do it. There it is. Got it. First try. Okay. Close the book. Got the bookmark. All right. I'm gonna sign off. Let me raid somebody on Twitch though. Let's see who else is. Streaming. Maybe talking about programming. Let's find someone. Let's find someone that looks like they're doing something interesting. Let's see. There's someone doing something about computers. Wow, this guy's huge. 16,000 followers. Well, that's like a million. Twitch is showing me an ad right now, which is really annoying. Cool. Let's go raid this guy. Oh no, he's hosting someone else. Never mind. Whatever. Let's raid. No, I don't think that's. No, let's. There we go. Somebody. No, that doesn't look good. Trying to find something good. Some good content. It's gonna be a surprise. I'm not letting anyone see. Surprise content. Let's see. JavaScript. So much JavaScript. It's pretty crazy how popular JavaScript is. All right, I'm gonna pick someone and I'm going to do it. All right. Thanks everyone for tuning in. Hope to see you next time. And I'll be back tomorrow. We'll get into chapter 7, cracking the coding interview. Thanks for dropping by. Catch you later.